Greetings, everybody, and welcome to Takeo Tuesday on this beautiful final Tuesday of June. I hope everybody's doing well. My name's John Barba, and I'm joined with Dave Holdorf. We are 40% of the Takeo Comfort Solutions training team, and we're happy to be with you today. And we have a wonderful topic for you that Dave's going to champion on air and dirt control and separation and getting gooky stuff and bubbly stuff out of your systems and why it's important. That's the technical discussion. Dave will give you the big view, but it's bubbly stuff and ooky stuff, right, Dave?
That's right. That's right.
That's
so
what we
we're
want
going
to
to
get
take
out
a
of
look
here.
at it. Definitely.
Alrighty. Before we get started, just want to make sure everyone can hear us okay. If you go to your control panel, you will see a chat section down at the bottom, and there you see it. Dave's showing that to you. If you can do Anthony Zizza's got it already, just type in a little hi, hello, how are you kind of thing, and let us know that you can hear us okay. And we also know that you know how to use the question and answer section, the chat section. So far, so good. Everybody seems, at least 4 of you, 5 of you seem to be able to handle that. So type that in. And folks, this is going to be how you're going to ask questions over the course of the next hour. Please make sure you ask your questions. We will be taking breaks every so often to address your questions. We do not like the whole, let's hold questions till the end, until we're done talking, then we want to hear from you. Ask your questions as they come up, and we will do our best to answer them as they come up. We'll stop every few slides. So that's a deal we'll make with you. Just one other word to the wise. Webinars, everybody's been doing these things for a long time. I mean, it seems like that's the only way we've had to communicate with each other over the past year and a half or so. Do me a favor, and to get the most out of this for you, treat this as though it were a classroom experience. Well, what does that mean? That means stay focused. On webinars, it's real easy. You know, I got the phone right here. I'm going to quick check Facebook, do a text or two, that kind of thing. It's easy to do, but to try to resist that. Keep your attention focused on the presentation. And the best way for you to do that is to take notes. Get a pad of paper and a pen if you don't have one already, and take notes as we go along. It's a great way to stay focused, and you have a nice little written kind of record of what went on during the presentation for you to review. Now, this presentation is being recorded, and tomorrow, right around this time, you will get a follow-up email from us with a certificate of attendance, as well as a link to view the recording. And you can view it as many times as you wish. There's no limit on that. So
I would say if you do pick up your phone and you are going to check Facebook or Instagram, take a picture of the screen and make sure you tag Takeo and say, hey, this is what I'm doing right now. That's the only time you're allowed, okay?
There you go. I like that. I'm going to do that right now, actually. Here we go. I'm going to take a picture of the screen. Let's go. Boom. Bam. There we go. Okay, that's going to go up on Facebook. Okay, so without any further ado, I'm going to turn the con over to Mr. Holdorf, who's going to take you through the wild and wonderful world of air and dirt separation and control. Take her away, Dave.
Excellent, excellent. Thank you, John, and thank you for everybody logging in and hanging out with this morning, this afternoon, or whatever time zone you're in at the moment. So today is a follow-up from 2 weeks ago. So 2 weeks ago, we talked about air in a system. We talked about dirty water in our systems, and how to combat it and why we don't want it in there. And today we're going to talk about the last part of it. So last week, just a quick little review, we talked about eliminating air. And the first thing we talked about last week was, hey, purge. All right, get the air out. That's one of the most important things, is getting that air out of the system. And I showed you a couple of different ways on how to purge and how to pipe the system out. Second way is pump away from your systems. Pump away from your expansion tanks / your air elimination devices. You pump away from that area. We know, as we talked about last week, this is going to be the lowest pressure in the entire system and also the hottest water. So therefore, it allows air to come out of solution much easier. Also, we talked about the pressure to maintain in a system, and over pressurizing the system or under pressurizing the system. And sometimes air problems look like pressure problems look like air problems. So making sure that you've got the proper pressure in your system is also very important. And then the last way we talked about eliminating air last week was mechanical devices, which I didn't get into. I just said, hey, we got to get rid of it, and here's another way. So and this is going to guarantee and really make sure your hydronic systems are air free. So let's really dive into the different ways mechanically that we're getting rid of air in our systems. So all right, so some of those mechanical devices, sorry, is the basic vents. Okay, we've seen these around. We're going to go into detail on these things today. I like to dive into the mechanical parts and pieces and really what's the guts on the inside. So we'll take a look at those. We're also going to look at the tried and true air scoop. All right, they've been around for a long time and not going anywhere, not going anywhere anytime soon. And then, of course, there's enhanced air separation. A lot of people talk about enhanced air separation as the only way, not necessarily. Let's just, make sure we understand what we've got. All right, when you're holding a hunk of metal in your hands and you're putting it into somebody's house, know why you've got it. So that's what we're going to talk about today. All right, so let's jump in and talk about the basic air scoop. All right, it is a basic, simple component, been around for generations. All right, it's a big old hunk of cast iron. All right, we've got a couple of notes on there. We've got some tappings on the inlet and the outlet side. We've got the tapping for our air elimination and another one at the bottom for our high vent. So really, really hard to put in wrong. All right, however, lots of times they are. All right, unfortunately, there's a couple of things you need to pay attention to. One is the print that's on there. And what I mean by that is there's the design on this thing, and it's not just for the water flow, as you can see here, but you want to make sure you see some words. And when you see those words on the scoop itself, make sure you don't have to turn your head or twist around and contort yourself in order to read the words. All right, once you can do that, it's going to be installed almost perfect. All right, so, but what's nice about the scoop here, there's no moving parts. It's very hard to say, hey, this thing was bad out of the box. Other than a visual inspection of it being smashed or driven over, then you would know, yeah, I'm going to have to return this or figure out why it broke. But no moving parts on the inside here. Like I said before, the high vent goes mounted to the top, and we're putting our expansion tank / fill valve tapped into the bottom here. Okay, so very, very simple component, but let's take a look at it from a little more details at the moment. And I want to describe to you why this shape is the way it is that we see in so many different air elimination devices. And it's that way because of how water flows. And of course, air is being lighter than water, and we want to have that air collection up at the top. Well, the other thing that we have also going on in here is some scoops, and these scoops are helped to deflect and move that air to the air vent sitting up on top here. But also, when we stop and think about it for a second, as we're moving water through our system, we also have a certain gallons per minute. We also have a certain velocity too. And that velocity is our feet per second. And all of a sudden, right past this point, if our flow is going from left to right here, right at this point here, we have this wide open area. And there's no air in it, right? Because the air has been removed, by the air vent. We've got air that's going to be in the water itself, and we want to get that air out. That the water, the velocity of the water has to slow down drastically. Once it gets right past that corner there, the velocity is going to slow down. Once that velocity drops, air comes out of solution a heck of a lot easier. So this is the reason for this design, why we have this big bulb. And flipping this thing over upside down now turns the vanes into deflections rather than scoops, and is not going to do the job for you. So that's why you want to make sure it is in the up position. And that velocity drops the water, air comes out of solution, very easy. However, something else must be happening with the water flow itself. And in a closed loop hydronic system, we typically have two types of flow. The first flow is going to be laminar. The second flow is going to be turbulent. And in case you're not sure what laminar is, it's the opposite of turbulent. Turbulent flow, you kind of know what that is just by the description. It's all mixed, it's all churned together, all right? Which means we want to have laminar flow of the water in the pipe itself as it enters the basic air scoop. You want to have laminar flow. Turbulent flow, which means everything is all churned up and all mixed up, means those air bubbles that could be entrained in there could easily be at the bottom of the pipe here and therefore just scoot right by the scoop itself, and they're gone. They're back out in the system itself and creating havoc for ourselves. So you want to have that laminar flow. When you have laminar flow, air bubbles are going to float to the top of the pipe, all right, and move along and then come into the air scoop itself. So you want to see that 12 to 18 inches is going to get you that laminar flow. Once you have 12 to 18 inches of straight, uninterrupted pipe, you can get laminar flow. And you get that laminar flow and help this thing do its job. Many times I see these things. You see the pipe coming right out of the top of the boiler. We put an elbow in, and then there you go, you're done. All right, and you throw the scoop in at that point. Well, the elbow is a major point of turbulence going to occur. It's going to disrupt and churn that water up, slams into the wall, gets all mixed up. So you want to have that 12 to 18 inches of straight pipe in order for this thing to do its job properly. So very important about that. So that's about it. All right, the basic air scoop is, like I said, it's been around for many years. And I say 12 to 18 inches because it does also depend upon circulator size, speed, and also pipe size that you're feeding along. If you want to just give a general number, call it 18 inches and be safe with that. And you'll get good laminar flow as you're flowing along into the system itself. So hopes that helps you out there, and maybe some of those job sites that you visited before, wondering why you always get airbound, might be a reason here when you don't notice that 18 inches of straight pipe. We get called into a job site, come take a look at it, and we start diving into the other components other than the scoop itself. So just something to think about. Again, keeping this downstairs at the supply of the boiler, want the hottest water, and of course pumping away the lowest pressure helps that air come out of solution much easier. All right. So while we're talking about the vents, because you still have to have that automatic vent sitting on top of the basic scoop itself, we've got a wide variety of different vents here, and I like to talk about a bunch of these things. Maybe you haven't, we've all seen them, we've all used them before, but maybe not pay enough attention to them. So the first thing I want to point out that we have a basic coin vent. All right, manual operation, can also be automatic too. And I want to show you that hydroscopic coin vent operation on the inside. And then we have our high vents in a lot of different sizes in there. We have 1/8 inch, 1/4 inch. We have 1/2 by 3/4 for individual, for different connections. Your 3/4 outside thread, 1/2 inch inside thread. And we also have this heavy duty 409 air vent. All right here. We use this in a lot of our commercial applications, and also throw it onto our larger air elimination devices for just the vent capabilities. So we'll talk about all of this as we go through. So first thing I want to point out is the hydroscopic coin vent that we have. And this is an automatic vent, which is pretty cool when you take a look at it, but it could also just be a manual open close vent. All right. So one of the things that's important about any coin vents, or if you have a hydroscopic coin vent being used in a system, make sure your system doesn't contain any glycol in there, because this is not looking for glycol. This is looking for a water system. You can also use this with some low pressure steam systems in the house and get that automatic venting going on. Make sure you don't point it in the downward position. The reason why, you won't get that automatic operation because you're going to see water settle down here, so it's not going to get you the flow or get the air elimination that you're looking for in an automatic setup. So when you are using a hygroscopic coin vent, in order to make it an automatic operation, you need to have it tightened down. All right, and when you close that down, then there are little discs in here. All right, and these discs expand and contract based upon moisture. All right, when they're dry, they constrict. All right, and that allows the air passage to happen. All right, on say a steam system, it's going to allow air to come in. All right, once it dries out, and that's what we want. We don't want that to eliminate that airflow coming in, but it's also going to allow the air to come out. And once they start getting wet, that's when they expand and seal up and keep everything on the inside. So, and even in a hydronic system too. So if it experiences any moisture, it's going to expand and going to close off the flow. Now, if you just want to open it, you take the thumb screw and you open it 1 to 2 turns in order to get that full open. As you can see, now the discs aren't in contact down below, and you've created a passage point there. So you have the knurled edges just for fingertips. You do also have an Allen key if you need to. And then I guess last but not least, pair of channel locks with a 3-foot cheater bar on there. I'm kidding. Okay. So we do have that available, like I said, and it comes in, you can set it up for a manual or auto operation. So auto operation, like I said, just tighten it down, not over tightened, just hand tight. And then those discs will expand and contract as they open and close and as they get wet and dry out. So any questions so far, JB? How we feeling out there? Everybody's still alive and still connected with me?
I'm presuming everybody's still alive. Let us know, folks, if you're still with us, and please type in any questions that you guys might have on this hygroscopic coin vent. I love that word, hygroscopic. That's one of my 3 favorite new words.
I'm glad I can facilitate that for you this week. So
and facilitates one of the other 2. So I'm not going to tell you what the last one is.
Awesome. Anyways, let's jump now into the high vents themselves. All right, and the high vents themselves, you know, it is an automatic venting system. You got a couple of components that you see in here. You got the cap, open and close. You want to close that down to shut it off completely. You just need to give it about a quarter turn and it's open. Another thing that we have built into these things is what we call a bubble breaker. It's just a piece of metal sitting out of the bottom here, and that bottom piece is any large bubbles that it might see in the water flow if it's in pipe. If you mount one of these things just in a simple T-style system, it's going to try to break up that air bubble to make sure it can come up inside of the vent itself. And the chamber itself, you know, there's a lot of space inside here. Believe it or not, I'm going to show you a cutaway of the float mechanism that we have in the inside. So it's going to hold a lot of air. There's quite a bit of air that can be held into these things. And I felt one of the most important things that we have with this thing is that we don't have a Schrader valve. All right. And for those of you out there that have touched Schrader valves, why do I consider this pretty cool not having a Schrader valve? Let me know what you think about that for a second. So, but we don't put a Schrader valve in this thing, and I'm going to hold off on that for a second, see if I get 1 or 2 answers that pop in to see why Schrader valves are sometimes scary to have in a hydronic system. So, and I'll come back to that. So, what's on the inside? All right, like I showed you before for a second, here's our float mechanism, and it actually slides up and down onto this little hinge point, which is a spring connected up here and going up and down. Now, when I take a look at the inside of the float mechanism, all right, it's not just a hunk of plastic in here, it's actually hollow on the inside. And with it being hollow is being able to keep that valve closed, believe it or not. It's going to have a little bit of air sitting up here in the top part of this float to help push it up. And when it pushes it up, it's going to make sure it's got a sealing point in here. Now, when the center part starts to overfill, all right, there is a little hole that you can see here. If you can see it there, there's also one opposite 180 degrees right through here that air bubbles will escape out to that and then start flooding the entire outside area. And then therefore, as more and more air enters in, it pushes down on that vent. So what is a Schrader valve? I see a question came in from Luis, and Schrader valve is like the valve that you see on a tire. All right, where it's got the pin on the inside. You push it down with your air chuck, right, to put air in. It's a valve. It's just a little pin with an O-ring around it. And for some people or some systems and some job sites, as soon as you touch that Schrader valve to try to let you want to manually let some of that air out that you think might be stuck in here, then all of a sudden it lets the air out. But what else does it let out afterwards? I'm sure you know, JB. What have you let out after you've hit the Schrader valve when you let a little bit of air out? A lot of times there we go, Anthony, a little bit of water starts coming out afterwards, right? And then it doesn't stop. So now it's just like you were just testing it out to make sure it was good, making sure there was no real major air in the system itself. And now you've got a drip on your hands and you've got other things that you need to fix. That Schrader valve with that little O-ring in there, I can find, can be troublesome, and making sure you have another vent around in order to replace it. Because one thing to remember is that a lot of the oils and the crud and everything else that we have in our boiler system is going to float on the top of that water. Since we don't have any real air in there except for what might be in the air elimination device is going to have a water air layer, a lot of that stuff can settle out in here and start fouling up any valves that you have. So that Schrader valve is one of those things that's going to get attacked pretty easily. So by not having a Schrader valve, it's just a positive shutoff. It's a rubber disc. I'll show you next what it looks like on the inside, is to help not have those leak points. Okay, so here's what we look at on the inside. This is just a straight through hole right up to the top here. All right, so I can even show you in the camera if we can get a good focus on it. All right, that hole just goes straight through to the cap. And there's just this rubber seat. So if you happen to have a Taco one and it does seem to be leaking, you're leaking some water out of that cap. All right, what I would take it apart, drop the pressure, drop the temperature in the system, take it apart and find that little mechanism. All right, and there it is. That's just a little rubber sleeve or disc you could just wipe clean if it doesn't seem to, just make any of that stuff that's floating in the water there, preventing it from getting a good positive seal. But like I said, that air bubble sticking in the bottom here is going to help that out and try to keep this thing closed as best as possible. All right. Hopefully that helps you guys out and understand what's happening on the inside there. So, I thought it was pretty cool once I started taking these things apart and making cutaways and just really knowing what you got on a job site is going to help you. Take these things apart. I know a lot of people consider these a consumable and just rip them out and put a new one back in again. Sometimes 5 seconds, you might be able to take that cap off and get inside there and just wipe it down. And you've got another working system again. It doesn't necessarily need to be replaced every single time, as long as we know, hey, it might be a little bit of oil, a little bit of something sticking on the top there. Couple other accessories that we have along with these 400 vents is, yes, I do know that we end up replacing a lot of these over time, and as life gets older with these things, we actually have developed a check valve to go along with them. All right, it is a simple screw-in check valve. Okay, what you do need to do with your vent though is just pull out the bubble breaker that was there. All right, get a pair of pliers, pull it right out. It pulls out in seconds, not hard whatsoever. And you go ahead and you can screw in your check valve hand tight. All right, don't need a lot of wrench on here. We do have an O-ring sitting on top. All right, and you just wrench that thing down. Okay, and then when you go ahead and install this into your system, and again, it's got a new bubble breaker, and here is the check valve part. All right, so right now it's pushed down, but if I were to start to take this one out, make sure you leave the check valve in, and as we start screwing down, then it's going to give us a positive seal, and you can go ahead and replace what you have. So that accessory has been added along, or can be purchased separately with there. Now, another thing that I really, really like, especially when these things are mounted not in the boiler room, they are someplace else around the house. All right, we have actually a drain connection that you can put to here. So rather than worrying about any of those fluids and oils and whatnot getting in here and keeping the valve mechanism opened, all right, you can take the cap off and then screw this piece onto here and then transfer over to a hard pipe or a vinyl tube or whatever, and make sure you vent it away or drain it away from anything that can cause damage, like sheetrock, when it's in a inconspicuous area that you don't see on a regular basis, like if it was up in an attic space. So we do have that. So you just put this little gasket right inside here, screw it down. Now you've got a 1/4-inch NPT transferred over, and rock and roll and do what you need to do from there. So, and here you can just see the other side of it. Okay, so this is what we'd be looking at the top. This is mounted right down onto that screw mechanism. Now, I do like to ask this one question. What do you guys like to do with these caps? Do you like to leave them open? Do you like to leave them closed? Something interesting to stop and think about. What do you do with these things? And sometimes when I do these training classes live and I ask that question, we're going to get 50% of the room one way and 50% of the other. We're almost coming to blows. So being that we're online, hopefully we're not going to have anybody coming to blows, but what do you like to do with that cap is what I'm asking you out there. So tell me how you like to leave that cap. Do you like to leave it open? Do you like to leave it closed? And I like both. How's that? How's that for an answer?
That
I know
covers pretty much everything. I personally, I'm an open guy. I usually leave them open.
I would
But
leave them open. I agree on that for, say, the first year, letting the air elimination device do its job and slowly, continuously get that air out. But after the first year, where's the air? You got it all out. It should have been removed by now. Now, I like to leave it closed before, for that reason of getting them fouled and leaking and nobody's paying attention to them. It depends on where they are in the house, or if you actually have used the connection systems to drain them away. If you close it, it's not going to be a horrible thing because you have this entire cavity to fill up with air that you might need to worry about. So leave it open for that first year that you did any major surgery to a system or major or new install. Maybe leave it open for that first year. But me, I say give it a close. Then once a year, you come back and open it up. And if there's any air in here, let it come out. If you seem to be getting a lot of air stuck in these things, then we need to revisit and take a look at where's the air coming from. If you leave it open all the time, you may never pay attention to a leak that may be occurring someplace in the house or in the system itself that you may not know, because the PRV is automatically, just putting more water back in, the air's coming out. It's doing its job automatically, but you may never pay attention to where it might have come from. So if you know it's a job site that you are going to service every year, then I would say close it and make it part of your routine to just give it that little quarter turn and let any air come out if there was any. And if there wasn't any, you're good to go and continue on. So that's just my thoughts. Maybe that makes you think about systems a little bit more and what you can get out of it. So just a simple thought there. All right. As we move along and jump into the 4900, all right, the Takeo 4900, our enhanced air separator. Now this thing is just amazing in trying to eliminate the air. It's just going to pull out so much air because of the designs that we have in here. Again, we have the big cavity. The velocity slows down. That velocity slows down. Air comes out of solution a lot easier at that point. We also have a stainless steel mechanisms or parts and pieces on the inside there. So if you have a glycol system, we don't have any worries. All right, we're not going to have any worries over time. And what's also nice about these things is that, one, there's no arrow on it, not like our basic scoop. There's an arrow, all right, and the reason for the arrow is to make sure that you got your scoops in the proper direction. But here we also have no arrows, and we also have no minimum pipe run. You don't need to have that 12 to 18 inches of straight pipe in here, because one of the things that we've done is added these pawl rings on the inside. We've added in a collision media, all right, which means air is going to collide with these pawl rings. These are stainless steel rings on the inside, and the water can change direction relatively quickly inside the chamber. But then the air bubbles are not. They're not going to keep up with the air moving to get to the other side. They collide with the pawl rings. Little tiny air bubbles glom onto those pawl rings, because now we've got a lot of surfaces on the inside. And then two little tiny air bubbles that combine next to each other, you start getting bigger air bubbles, and then the air floats to the top and is then let out by the venting chamber up atop. So those pawl rings really, really help get the air out fast and easy. These things are worth their weight in gold. How many people really, really, and truly enjoy purging? Hands up. All right. And if you raise your hand, thank you. If you did that sitting there by yourself. Nobody really does enjoy purging, right? What I like about putting in an enhanced air separator like this is that you burp the system. You get some basic water flowing into the system itself, and then let this thing do its job. This is just going to continuously pull that air out of there for you. And just so you take a look at it, we do have very, very high CVs here. Very high CVs. So very, very minimal pressure drop that you're going to see here. Same thing with the basic scoop, has also a very high CV. I don't remember those off the top of my head. Very little pressure drop that we have. And these are listed all the way up to 2-inch pipe size in the brass configuration here. We do make these all the way up into 36-inch pipe diameter when we get into the commercial side of things. So it looks a little bit different. We roll the steel ourselves, and we have the basket of these pawl rings that get included in there. So here you can see a little bit of that pawl ring itself. It's just some stainless steel with some tabs that are bent around. All right, and the little air bubbles enter the inside, and they're just laid in a basket. So there's lots of different openings on where the air comes in, and then they get larger and just float themselves out. So as you can see here with this little animation that I got going on, you can see how the air comes out of solution, pushes down on the vent, all right, and the valve opens up to get that airflow again. And how'd you like that, JB, huh? That's a new addition that I found.
That's pretty cool. I like that. I like that.
So,
looks like a dragon.
They're really going to pull that air out fast and easy. It is amazing as you're cleaning tools up for the day. I like to jack the pressure up in my system as high as it'll go when I start. And this thing is going to start just hissing out that air. And as you're cleaning up and putting things away, you just keep on hearing it. The pressure starts to drop in your system. And then you get it down to your working pressure when you hear it not really hissing any longer. So let me talk to you about a couple other things with the 4900, which I think is just also some really cool designs that we put into here. So the first thing is this conical shape. Why do we have that conical shape sitting up on top? So many of them are out there have a flat top. It's basically a tube sitting there, but we designed it to have this conical shape. Really important. Remember what I was talking about with the 400 style vents. Why don't we have a Schrader valve in here? Because we don't have the cleanest water possible. Same thing here. Same thing here. The reason for this conical shape is to actually leave more distance between the surface level, all right, of the water to air to the valve mechanisms that we have sitting up on top here. We don't want to get them fouled up. So by getting them fouled up, we're going to have leaks, it's dripping, things like that. It won't get a positive seal, or it may not positively open to let enough air out. So by having that conical shape in there, we're still going to leave air in here, but we just create the distance between the water air level to the mechanisms a little bit further away. All right, so that's why we have this weird shape to it. It's not just to make it look different. It's actually got it serves a major purpose that I think is really critical and give these things really, really long life behind them. A couple other cool things that I want to point out that we have. If you noticed in a basic 400 vent, you want to leave these things relatively parallel, all right, and perpendicular and stuff like that. You don't want to have them too cocked around, because now your float mechanism might end up riding along the brass on the inside in there. And if it's got too much of an angle on there, it may not move properly. Very inexpensive devices. Like I said, a lot of people consider these consumables. So what we did on the inside of this one here is that we actually have a couple of guides. So you have a guide here that's going to hold everything in place, that allows the float to go up. And then we also have a guide down here on the bottom that's on top of the basket of your pawl rings to help the float also just go up and down, so it's not going to bind or get stuck anywhere. So a little bit of extras that we've added to make sure that if you don't have it perfectly level, that it's going to still go up and down and do what it's supposed to do. Okay. So I felt that's a really cool design once you really dive into it and take a look on the inside. And then the other part that I thought was really neat and interesting, underutilized, and people don't know it's there because you didn't look at it. All right. Right here on the end. All right. We do have a positive shutoff. Just get yourself that little screwdriver that we have. I think I got mine right here. There we go. All right. Get yourself your little screwdriver. All right. Tighten that down and you've got positive shutoff again. Again, big chamber to hold off some air, that hold that air inside there, but you can shut it off. I like to shut it when you're starting to do that initial purge, because otherwise this thing starts bouncing up and down. And when it's bouncing up and down, it's spraying out, in and out, in and out. And you're going to churn a lot of that water up on top in here. And of course, that's your initial fill, which has the dirtiest water in the system. So close that thing down so it's not going to be seeing any of that air come out just yet. start doing that purge, and then I open it up and let it do its thing. So, and then the outside here has been machined to accept vinyl tubing to slide over it. So if you do have this in an area that doesn't allow any water to drip underneath it, put the vinyl tube on it, bring it over to a drain line. So it has been machined, so you can just slide the tube on it. It'll be a tight fit, so you don't have to worry about it. If you want to put a hose clamp on, go for it, but you probably won't need to because there's not going to be any pressure behind it, right? If it's just a drip or two coming out. So that has been built into the 4900 air separation. And so therefore, when we look at the 409 vent that I showed you earlier, the high capacity, that's just basically one of these just threaded at the bottom. So you still have all of that parts and pieces that I show you here is also involved in just the 409 vent, just the vent body itself that we see on our commercial applications too. So hope that makes sense to you all. And I am going to just grab a quick slug of water here. Thank you for your patience. And so here you can see our basic install showing our the 4900 vent, our expansion tank, PRV tying into the system. All right. And these are in 1/2 inch NPT and as well as press connections. And like I said, up to 2 inch. All righty. So now as we end the air elimination side of things, we're going to jump into the water filtration side of things and cleaning up the water, our dirty water systems there. All right. And we talked about this last week. We talked about, all right, what do we do if we end up with dirty water? We saw that it affects our boiler efficiencies. It could affect component life, a lot of things that dirty water is going to affect. And whether you're looking at cast iron boilers or your wall hung condensing boilers, even more important, boiler technology has changed. So it says, all right, we need to flush and clean our systems. There's plenty of chemicals and a lot of manufacturers out there that make some really high quality stuff to really clean out your systems. And whether they're new or even older systems, there's plenty of stuff out there that you can run in there. And then of course, there's the mechanical removal. All right. That's going to continuously treat it for the life of the system. That's the important thing. Flush and clean and the chemicals is, usually on day one. The mechanical removal is now going to make sure it stays clean after you put all that time and energy into doing it first. Now, one of the things that's about flush and cleaning a system, how many people here, and please be honest, have taken a brand new system, filled it up with water, purged all the air out, got it all done, stopped, opened all the valves, drained it, and did it again? Come on, raise your hands. How many people have done that?
Well, not intentionally. I've done that by accident, but never intentionally.
Right. Oh, yeah. That's when you filled it up and you're like, oh, that one's got a couple of joints that are leaking on you. Yeah, exactly. Yeah. No, actually, if you take a look at a lot of the boiler manufacturers' manuals, that's what they require you to do. Cast iron, ModCon, they want you to flush the system down. All right. At that point, people are looking at you, wait, I just filled it up. Why do I want to drain it down again? All right. So flush and clean is actually one of those things you need to do with every system. So, but the mechanical parts here, putting in a magnetic dirt separator is going to help eliminate a lot of that stuff. It's not going to eliminate the requirement from the boiler manufacturers. Still do what they want you to do, to make sure that boiler is going to live a long life and also meet the warranty periods that they're looking for too. So here we'll just take a look at a quick little piping diagram showing our air separator again on the supply, the hottest water, our expansion tank pumping away. This is where we like to see air separation going on. And then on the return back into the boiler is where we like to see magnetic dirt separation. All right, we want to make sure we get the components out of the water before it feeds back into the boiler. Probably your highest investment component that you have in your entire heating system. Let's make sure that we protect that too. Okay. So we have a couple of things to enhance the dirt separation out of there. And it looks, if you take a look at the dirt separator, kind of looks very similar to the air separator, right? I'm sorry, let me flip that over. There you go. Yes, very similar in design, right? Here's your magnetic dirt separator. Here's your air separator. All right. Yes, it is. All right. And a lot of the same technology is from one to the other. All right. So we do have those Paul rings. Those Paul rings are all over this magnetic dirt separator in here. Same idea. Those Paul rings that I have. Let me pull that up for you there. All right. Take a look at those Paul rings there in the center. Same basket of rings that we see in there. That water can change direction really fast. However, the dirt doesn't. Anything that's suspended in any solid that's suspended in the water itself is going to come out of solution. The velocity drops, the same idea. The velocity drops, the Paul rings help. They're not going to glom on. They're just going to make sure they change direction and fall down to the bottom. Okay. So that's what we're looking at there. Now, the other thing that we have when we say magnetic dirt separator is the magnetic part of it. And the magnets, as you are seeing here, is this black plastic ring around the outside of it. And it's a 13,000 Gauss magnet that you have here. And here you can also see the CVs. They're actually higher than they were for the air eliminator. And it's just because it's a different design chamber-wise. All right, it's not exactly the same because we don't have that float mechanism anymore. But still very high CVs for what you're looking to do. Okay. So this magnetic ring, this plastic ring gives us a 13,000 Gauss. And I bet a few of you are like, wow, that's pretty cool. 13,000. Wait, what? What's a Gauss? All right. Yeah, I pulled this right off the marketing page. But I like to talk about Gauss and what is Gauss. All right. 13,000 Gauss might sound amazing. All right. But in the world of magnetic dirt separators, I'm going to pull out a couple other manufacturers that you may have known about or heard of or even worked with. Right. The Fernox TF1, that's 9,000 Gauss. Now, if anybody has seen a Fernox one, and I've seen it plenty of times, they have this really large magnet, and I go to a lot of the trade shows and I see them picking up my circulators with the magnet. All right, they just take that magnet and bang it onto the cast iron flange and lift the circulator by holding the magnet. All right, and wait, what? There's this 9,000 and we're 13,000. How the heck? I'm not picking up a circulator with this. All right, the dirt mag is 2,600. The 80 is 11,000. So what is Gauss anyway? Gauss is not magnetic strength. It's flux density. It's the magnetic density of the magnetic field itself. All right. So for example, when you take a look at a bar magnet like this, the Gauss is really low. All right, because the lines, if you notice, are really far apart. But now you go ahead and put north and south near each other, the magnetic field lines become very compact. And therefore, your Gauss number starts to go way up. And obviously, you take a look here, all right, when you put the same poles together, they are almost nothing in the middle, but then it's just the standard strength that you see as you get a little further away. So that's what we look at with this ring. We have these series of magnets all around the outside, so therefore the inside, the Gauss number, the magnetic field lines is very high. All right, just because it's a high number or a low number, as long as it's actually getting the iron oxides and the iron components out of your system is the most important part. Okay, so the design of the magnet, some of those ones, like the TF1 here, when you can pick up a circulator, it has to, because it's a magnet that goes in the center, and the field lines, the magnetic flux density is actually weakened the further it gets away from that magnet. So that's why. All right, so just so you know, when you pick something up, like I said earlier, why do you have this in your hands and why you're putting it into somebody's system is usually the most important. Make sure you know why you've got a particular component out there that you're going to use. Okay. So here we take a look at the inside of our system here. You see those Paul rings themselves, and we have the chamber down here. All right, so the Paul rings, again, no direction. All right, velocity changes, stuff comes out of solution relatively easy. And as it's coming down, and then any regular dirt is going to continue all the way down to the bottom and fill up the chamber. Now we do have that magnetic field in here, all right, and the ring itself is going to attract and make sure any steel components, iron components are going to stay here in the chamber and not come out and go back out to the system itself. So it's going to even get that really fine bio, the black iron oxides that we can see out of the system, and it's going to hold on to it there. So again, same principles as our air separator. Excellent, excellent. As I move along, any questions, JB? How we doing out there?
You're doing quite well. The questions have been kind of non-existent since you want to ask whether people like their events open or closed. So again, folks, any questions, please type them on in. This is a good chance to ask a guy who knows what he's talking about, what the heck he's talking about. So
and the reason why I also ask questions is to make sure that we didn't get disconnected either. All right, there's nothing worse than a webinar going on and the trainer still talking and to nobody. So that's also the most important part. I know it's lunchtime and things like that. So all right. So with that being said, I'm going to continue on
and Dave, just to stave off panic, somebody type in hello, just so we know you're out there. Just so we're not panicked that we have somehow lost our entire audience. There we go. Okay. Some people are with us. Excellent.
Excellent. Thank you, Vic. All right, now I see them. All right, I just got to move out of the microphone there. I can see them. All right. So good. So I know sometimes I can be very thorough in here, and maybe I don't have any questions. But I just wanted to make sure that we're still connected to people. I think there was one time John and I were continuing on for about 5 minutes before I got a text message saying, dude, you got disconnected. So anyways, so how to work this thing. All right, very simple. Install it in up to 2-inch in your pipe size and you're done. All right. Now when we take a look at it, we do have a shutoff cap. All right, so when it's not being serviced at the time, you leave that cap in place. We do have a barb connection, so you hook up a hose to it if you wanted to. If not, we're just going to use it and grab a cup to it. So first thing, when you want to clean out your system, and I suggest maybe doing this once a year when you're doing your basic service. One, all right, the boiler doesn't have to be hot or cold, probably easier if it's cold, so in case you don't have a bucket or anything like that nearby. Two, most important, turn the circulator off. Any pumps in your system should be off. Let the water settle out. All right, we don't want to get it all churned up at the time. All right, so then next, what we're going to do is remove the cap, put the drain on there, make sure your valve stays closed, and then the ring just easily pulls off. There's a little gap in the back here, as you can see here in the picture. All right, we're just going to slide it back and it pops off. All right, very flexible plastic. I'm going to say it's going to be very hard for you to break it. Don't try. I know someone's going to say, oh, I'm going to really try and break this thing. I mean, it's very flexible. We got some grooves in here to really help it flex out for you to slide it back in. So you slide this off, okay? Once it's slid off, now what you can go ahead and do is open up that valve. 3 to 5 seconds, tops. 3 to 5 seconds is tops that you want to do. Get any of that dirt that's coming out of the system itself, because now when you pull the magnet off of there, any of the iron components that were stuck to it, now the piece of brass that's left in here, not very thick to allow that magnetic field to pass through it, and now it's going to settle down to the valve head, and then you open it up and you're done. You purged, close the valve, replace the cap, put the ring back in, and you're done, ready to rock and roll. That's all you need to do. So very, very simple system in order to get the dirt and any iron components in your system out. So excellent. Thank you for that comment, Rodney. Colin, you're welcome. So for the Gauss thing there. So I thought that was an important thing, especially since our marketing department also put it on the paper right on the front page. And it was just like, I got to do some research on that, because sometimes we just gloss over it and don't pay attention to it. So with that being said, I am done. All right. So, and I saw this, I had to pull it up. I know, using the Taco Tuesday themes, I just thought it was fun. All right.
I like it.
So with that being, yes, sir.
Sometimes things just work out. The whole Taco Tuesday thing has just, it was opportunity met preparation there. So Taco Tuesday is here. And again, I'd be interested to know how do you guys feel about the weekly format? Now we go commercial, residential, or commercial, residential for the month and doing them every week, if that works for you guys. So just let me know that. And then there's a question for you. Can you use that on domestic water? Asks Rick Davis. And I'm going to guess you mean, Rick, the dirt mag separator.
Correct. Yeah. I'm not 100% on that. I'd have to take a look to see if we have any NSF ratings. I mean, we may not have an NSF rating on it. And
I
the
don't believe
brass
so. I don't believe that's lead free. Yeah, I don't believe that's lead free brass.
Yep. So I would probably say no. Technically, yeah, but the brass is probably, and we're not going to rust up, obviously, but yeah, I wouldn't use that on the domestic side of things. And on the domestic side of things, you're probably looking at a smaller micron that you want to try to filter
Right.
out of the water itself, where this is going to get the big chunks. You got big chunks in your water coming in from the street. We got other issues to talk about.
Right. Right. Yeah.
So talking about, and keep the questions coming. Thank you. But just figured I'd let you guys know that next week, so no, you have not received an email. So next week, we are not doing Take-O Tuesday, July 6th. We're going to leave the holiday week open. We know a lot of people take off that week since Monday is the holiday for a lot of people. So we are not doing Take-O Tuesday on July 6th. July 13th is going to be our next class. And the next class is going to be something new, very interesting. It is also going to be residential focused. Technically, it should be commercial, but it's our next quarter that we have going on out there. And it is going to be residential efficiency ratings for circulators, which my counterpart, Mr. John, is going to be focusing on. It will be posted soon on the website, and you should see an email coming from us soon about that, on how to sign up. And for the next bunch of classes would be announced all at the same time.
And what this is about is by the end of July, you will see your residential circulators coming through with energy rating labels on them. And it'll also be on the packaging. Energy rating labels like you see for other types of appliances, where it says least consumptive or most consumptive, and somewhere in between. And that's going to be part of our lives. The Department of Energy is not regulating circulator efficiency yet, although those discussions have started, and there is currently an ongoing public comment session. So that's going on right now. What that means is, will we have circulator efficiency standards that must be met for small, meaning 1 horsepower and below circulators, like we have with 1 horsepower and above circulators in the commercial world? I would say that yes, that almost will certainly take place in the coming years. When is still open to discussion, but I'm certain that's coming. And this is maybe a first step, that you will see these energy efficiency ratings on your circulators. So what we're going to do on the 13th is kind of break down what those ratings mean. How did they arrive at them, and what purpose do they serve? And hopefully we'll take a little bit of mystery out of that, so that when you do see them on your circulators, you'll know what the heck, as Dave has said, you'll know what you're holding in your hand and why you might want to use it for this job. And I think you'll be very impressed with some of the ratings and what they mean. So that's going to be a lot of fun. And that will be July 13th, Tuesday, yes. July 13th at noon Eastern. At noon Eastern, just like this one. So cool. All righty. Hey, I hope you guys enjoyed the presentation. Dave, as always, does an awesome job on this particular topic, like he does on every topic he discusses, and it's a very rare guy that can make air separation kind of fun and interesting. And you do a really good job with that, and you make it pertinent, and you make it relatable. And why is this stuff important in somebody's jobs? And I appreciate that. It was really well done.
Thank you.
And you will be getting, again, to repeat, you'll be getting an email tomorrow. Oh, by the way, before you guys check out, also make sure you go to your handout section and download the handouts for today's program. There are 4 handouts for you to download. So please make sure you do that before you hit the leave webinar button. So you will find 4 items in the handout section: the Take-O residential product catalog, as well as some PDFs on some different products, the 4900, the Dirt Mag Separator, etc. So you'll see those in your handout section. So make sure you download those and keep those in your library. With that said, Anything, any parting shots you'd like to add, Dave?
No, I do. I know it's hard to focus on heating when it's 90 degrees outside, for
Or
some of us
worse,
anyway.
or worse, my goodness, in some parts of the country. Good
Yeah.
Lord.
So, but guess what? Heating season comes every year. I've seen it. And it's gonna hit us hard and like it always does, and we're never prepared for it. We're never fully prepared because we're still doing other things. And you get one breath after air conditioning system, and then there you go. It's heating season again.
Right.
So that's still going on. Yep, I understand. So, but I do want to say thank you to everybody coming by and hanging out today. It was I really enjoy this format that we've been doing, as in where we talk the theory one class and then we talk about going into the deep dive onto how to use these things. We talk about why a lot. We talk about the whys. Now we're doing the how. How to
Mhm.
use this thing and what's going on the inside. So it becomes easier for you to use the next time and to service and take a look at it. So that part is fun. That part is fun to me being an ex-machinist, I love ripping these things apart, and you know, I love tinkering down in the garage and messing things up again. So for those of you, I love this, doing cutaways. So I got to make some more stuff cutaways.
And if you're ever with Dave, don't stand still too long because he'll try to cut you in half too, because to see what's going on inside. He's kind of
Well, I
like
know what's
that.
on the inside. It's a lot of yuck, and it's just going to
Yeah.
spill out. So
All righty, folks. Well, hey, thank you so much for the gift of your time today. We do very much appreciate it. Hope it was worth your while. And we look forward to seeing you in a couple of weeks. Have a wonderful 4th of July holiday weekend. And as Daniel says, stay cool out there, my friends. It's dangerously hot in many parts of the U.S. And I hope everybody stays safe, stays cool, and we'll see you on July 13th. Take care, everybody.
enjoy, all.